Okay, let's start chapter 4, congruent figures. We are going to learn what congruent figures mean. We have so far learned congruent segments and congruent angles. Now we're going to learn congruent figures, and we start with triangles, okay? Let's first think about what congruent means. So these are the warm-up. These are called tessellations, and it's spelled like this. If you type this in Google, you will see many different tessellations. It's basically tiled up different figures so that there is no space in between. So all these little birds are all congruent, and they are rotating through, and then it fits perfectly. So here there is a 4 figures to form 360 degree. Here is another tail, the 4 figures forming 360 degrees. You remember we did the tiling to make a floor? It's like that we need the figure to fill out all the spaces, and here there's a 4 figures meeting here, and so forth. Again, 4 figures meeting here. You can make tessellation with an hexagon and any other. You have to be able to make the corners add up to 360 of different parts of different corners shaping up like this. So that's a tessellation. But the point is that these are all congruent figures. The tessellations are made by rotating and sliding congruent figures. Or you can flip them. You see this trapezoid, no, it's not trapezoid, this is quadrilateral. It's flipped over here and then flipped over here. It's flipping this way and flipping this way. You can make a tessellation by flipping as well. These two problems, I want you to do this, think about it, and we start with this in class, okay? So these are homework. Okay? All right, so in chapter 4, we have 7 sections, and we are going to do all of them, okay? We probably going to do quiz here, and then a test, okay? And there are 3 objectives for the first 3 sections, actually 1 objective per section. So for this section is identify corresponding parts of congruent figures. Identify the corresponding parts of congruent figures. Okay, all right, congruent figures and congruent parts. Whenever 2 figures have the same size and shape, we already learned this concept, the shape and size being the same to make it a congruent, right? The size will make the equal part and the shape makes the squiggle part. They are called congruent. You're already familiar with congruent segments. Segments have equal lengths, and congruent angles, angles that have the equal measures. And in this chapter, you will learn about congruent triangles. Okay, so here are the congruent triangles. Triangles ABC and triangle DEF are congruent. If you mentally slide the triangle ABC to the right, you can fit exactly over triangle DEF by matching up the vertices like this. A gonna go on the D, B is gonna go on the E, and C is going to go on F, and then it's gonna exactly match up. If they are congruent, it's gonna exactly match up. It could be flipped or rotated, they are still congruent. It doesn't have to have the same orientation for a triangle to be congruent. Okay, so you will see that. Well, actually, you saw this in tessellations, right? These are congruent quadrilaterals. The orientations are not the same. But if you flip it or rotate it and then it gets on, it overlap completely, then they are congruent. Okay, and the size and angles will then match up like this. Well, we did the angle there. The side AB is going to match up with DE, AC is going to match up with DF, and BC is going to match up with EF, right? Those are called corresponding angles and corresponding parts. Very important concepts. If you slide and or rotate and move and overlap, the parts that overlap are called corresponding parts. Corresponding parts. Corresponding parts. The parts meaning angles and size. Okay. Congruent parts. Okay, two triangles are congruent if and only if their vertices can be matched up so that corresponding parts, angles and sides of the triangles are congruent. Okay, so that means that corresponding parts, in, like for example, these segments are congruent, meaning have the same length. See that these tick marks, corresponding parts are congruent. Corresponding angles are congruent, meaning have the equal measure. Right? When referring to congruent triangles, we name their corresponding vertices in the same order. For the triangles shown, triangle Sun, SUN, is congruent to triangle Ray. So you write it like this. Triangle Sun is triangle Ray. It's important to name the triangle in the, this is called congruent statement. You have to go in the corresponding order. S correspond with R. U correspond to A. And N correspond to Y. Okay, you have to go in the corresponding order. Otherwise, you're going to lose a point. You're not going to get full credit. Suppose you are given the triangle XYZ is congruent to ABC. From the definition of congruent triangles, you know, for example, that segment XY is congruent to segment AB, because it's going to go in that order. So AY is going to be congruent with AB, and YZ is going to be congruent with BC, and so forth, because angle X corresponds to angle A. Okay? Congruent polygons. Two polygons are congruent if and only if their vertices can be matched up so that their corresponding parts are congruent. Okay, so this is the definition of congruent polygons. Here's the definition of congruent triangles. Two triangles are congruent if and only if their vertices can be matched up so the corresponding parts of the triangles are congruent. This is definition of congruent triangles. Congruent polygons, pretty much the same. Okay, just for the triangles, there are many ways to list the congruence between the two pentagons. Just as for triangles, there are many ways to list the congruence between two pentagons. Here, these two pentagons are congruent at the right, so the corresponding vertices are written in the same order. Notice the side KE of pentagon break corresponds to the side KE of the pentagon choke. KE is called common side of the two pentagons. Okay. Okay, so these are congruent means all these sides, the corresponding parts, has the same length. Okay, just to make sure you're getting this. So 4, 2, 3, 4, and this is shared, right? And these angles are congruent. These angles are congruent. These angles are congruent, and so forth. Okay. All right, let's go to the practice. Let's go through this practice. 2 more pages, and you're done for the day. Okay. All right, so suppose you know the triangle fin is congruent to web. So let's just write it out. Triangle fin is congruent to triangle web. Okay, now name the 3 pairs of corresponding sides. So let's do this. Stop the video and do it now. The side and angles, and come back. All right, so the side, the segment FI is congruent to segment. You're going to go in the congruent order. So WE, that's the first one. Segment IN is congruent to segment EB. And segment NF is congruent to segment BW. If you didn't write in these corresponding orders, then it's incorrect. Okay, it's important that you go in the right order. And angles, so angle F is congruent to angle W. Angle I is congruent to angle E, and angle N is congruent to angle B. Okay, if Is it correct to say that NIF is congruent to BEW? What do you think? I went with corresponding order, right? NIF and BEW, so this is correct. Is it correct to say that INF is VWB, EWB? I went this way, I and then N. This one is go E and then W. So no, this is not the right way to say it. Okay, you see the difference? You have to go in the corresponding side. Corresponding angles have to be in the corresponding order. Okay, these problems 5 through 11, I want you to do this as a homework. I think you can do this. Okay? All right, and let's go to the next page. The pentagon shown a congruent, complete. I think you can do this too. 17, the 5 leaves shown are all congruent, but one differs from the others. Which one is different and how? Oh, this is a fun one. You should do this one. Okay. One is different and how. All right, and then we got 18, 19, and 20. Name the coordinate point of A and B and C. Coordinate of this, you can do that, right? Name the coordinate of the point D such that triangle ABC is triangle ABD. ABC is triangle ABD, all right? So you can do this, I hope. Name the coordinate of the point G such that triangle ABC is triangle EFG. Is there another location for G such that triangle ABC is triangle EFG? Okay, so there's an E and F here. So you gotta find, okay, so I'm gonna do the first one. So EFG. If G is here, the triangle GEGF is congruent to triangle AC, ABC, and EFG. Yeah. Now think about where the other G can go, or for location for these to be congruent. Okay. Name the coordinate. So what? Yes, this is homework, right? And this one is homework. And name the coordinate of two possible points H such that ABC is EFH. Okay. So this one's a little tricky. I want you to think about this, okay? So, EFH, you see that? I mean FEH, the order flipped now, so like A corresponds to F and B corresponds to E. That's the difference. This one was ABC is EFG. This one is ABC is FE something. Okay, so that's a homework and we are done. See you in the class.